Hello everybody to this first demonstration of um, the SmartCollectives platform in the scenario 2. In this video we will talk about the configuration of scenario 2. Since it's a more complicated scenario, it requires some configuration and setup to perform properly. Well, let's dive in. We have, for one, the scenario 2 main Java file, which defines two Boolean variables, demo and variant A. As you may know, the scenario 2 wants to demonstrate our failover behavior and also the option that a orchestrator may want to have some choice during a common scenario. It's basically an extension of our scenario 1, which was a simple restaurant Q&A, and in this case not all answers are sent to the requester, but the orchestrator may pick one answer as the final answer. This variable, the variant A, is defining if we are going for a manual recovery from error defined by the programmer, or with our automated recovery as described in the paper. The demo variable, on the other hand, defines if we want to use an embedded mail client or if we are going for a real mail client. Sorry, my mistake, not mail client, mail server. It actually allows us to start up an internal server which is running on the local host instead of connecting to real providers, which enables us to demonstrate the platform also when there are problems with the internet or when and also in shorter time, since connecting to real providers takes some time and even more configuration. As you can see, there is a second part where the demo switch works. In this case, we're exchanging, if the demo is on, we're exchanging the email output adapter, the default one, by our custom email output adapter, which is configured to work properly with our local mail server. This is due to the self-sent SSL certificate of the local mail server. We have to use other SSL factories. However, this is a nice point where you can see how customizable the platform is and how easily you can simply switch out existing communication adapters with own communication adapters if you have to integrate something which wasn't thought of by us in the first place. Now, besides these 2 points in code, we have also a few configuration files we want to have a look at. The first one is the email adapter properties file. It's a straightforward configuration for how the platform itself can access its email account, where it can receive requests and respond to requests and communicate also with the queue. This is an example configured for working with our local email client, and you have also a not used example of how to configure a potential Google account. Please note that here you will have to enter a Gmail access token for third-party software, which can be retrieved at your account settings. The next thing is the Google peer properties file. This one is basically configuring our software peer, which is used in this example, which is basically a Google search engine. Since it's a custom search engine, you have to specify the ID of the custom search engine, and also you have to provide an API token for accessing it. Both can be obtained from Google. We have the search engine custom search engine homepage, which is cscsegoogle.com. And we have here already prepared a Yelp Smartphone demo search engine, which can be easily added by adding a new search engine. In the detail view, we can see that we have registered to search on the Yelp.com, and our search engine ID, which is visible here, is the one we have pasted in our property file. For the API key, you have to actually go to Google APIs, or better, the Developers Console of Google, and you have to activate the custom search API. And after activating the API, you can request a access token, and this is actually the token which was used, which is also pasted into the property files. Please note that although visible in this video, this token will not be accessible after this short demonstration. Okay, let's continue. The last one is the peers JSON file, which defines which peers will be existing in this scenario. As you can see, the very first one is the Google peer, which is a software peer. The communication type is over REST, and the channel where it can be reached is localhost port 8000. The rest of the peers are human peers, two community peers, which are human experts, and one orchestration peer. All three can be reached by email and have the local email addresses set as communication channel. If we would have a look on an example for a setup with real email addresses, this could look somehow like this, where we have simply the complete email address instead of the local email address. This scenario is not limited to these peers. By simply adding more peers to this file, you could make it work with a bigger example community, which is not really necessary in our case. So let's start. For the very first demonstration, we want to run everything in variant A. This means that our developer has decided that he will handle timeouts and exceptions himself. This could look something like this. He has an initial CBT which he starts, and when an error happens, he could incentivize by using means of our platform his community to act more on requests, and then start another request to the community. These 30 seconds here are only a simple placeholder to simulate a failure. It is simply for demonstration reasons, so we don't have to wait too long. This is a placeholder for our incentive service, which is integrated, but due to the missing API of the peer manager, we couldn't show it here in a better way than a comment. So, okay, let's run this one. We can simply run scenario 2. It will now start up everything, including the email client. Speaking of the email client, let's have a look on how we can actually access this thing. For the email client, you will need an external program like Thunderbird, and you can configure the local email addresses. Now, since it's an embedded email client, you have to first start the scenario to be able to actually configure the local email addresses. As you can see, I have already everything set up, but for purpose of demonstration, I will delete one of the accounts again and show you how to set it up. Okay, here we go. So I deleted the peer2 localhost email address, and I will be adding it again. So here we have peer 2, and it's peer 2 at localhost, and the password is also peer 2. Basically, the password is the name of the user himself. It's all configured like I already showed in the QSJSON, and basically this is also the password for the account. Now, never mind this exception here. It's just a warning. We can go to the extended. We must go to the extended configuration where we can properly adjust the settings. For the ports, we have to use the unencrypted port and with an offset of 3000, which is in case of the SMTP port 3025, and in case of the IMAP port 3143. After entering this, we can retest, and we'll see that Thunderbird will find the settings. By clicking done, we will get this beautiful warning that it's an unencrypted connection, which is fine for us. It's a local server, and we want just to use it for the demo. And after that, we have set up our email, and the last thing we have to do, simply to avoid further conflicts with Thunderbird, is to disable this copy on send and archives, since it's a very simple email emulator we are using here, which was designed for unit tests and integration tests. We don't want, it actually doesn't support send folders. So, okay, after everything is set up, we can misuse one of our peers as the initial requester. The only thing which has to be correct here is that you have to use a peer which is known to the platform. Otherwise, it cannot properly respond to the privacy settings. So we could create another peer for this, or we could simply use the peer orchestration manager. And by entering here the localhost email address and RQA as subject, we can send a request, like for example, Japanese in the Vienna 4th district. Now, the RQA stands for restaurant question and answer, and is the key which will be used by the platform to identify this as request for this service. Now, we send this, and the first thing that happens is that our community peers get the request. We will now ignore this request since we want to demonstrate the error cases. Remember, in variant A, this means we have a set timeout, and afterwards we will get a new request. Let's refresh this a few times until the timeout hits. Yeah, it's 30 seconds. It's not that bad. Here we go. As you can see, we got another request. Now we will answer this one since we want. We are already in recovery mode. We are entering some restaurant name here, and yeah, here was in peer 2. Okay, and now our orchestration manager will get a mail demanding to choose which one. As you can see, very nicely, we have here both human opinions, and we have also a Google result list, which has 5 of the Yelp responses as described in the scenario in our paper, and the PMR orchestrator can now reply and say which is the chosen restaurant, and let's go for the Machi again and send this. Okay, welcome to the actual presentation of our scenario 2. We will demonstrate in this video the variant A of our scenario. Variant A is the variant where the developer himself defines manually what kind of error management should happen in case of a failure in the execution. We simulate this failure in the execution by setting a very small timeout on the first run. This can be, however, anything else defined in one of the handlers, like a failure in the execution, for example, a community not answering to the call or anything else. Afterwards, the developer can, depending on the error type, decide what to do. For example, he could incentivize his community and then re-trigger the task with different parameters or with an incentivized community, which we see here. We have further two timeouts. One is for 2 minutes for the community answer and 2 minutes for the orchestration, for the answer from the orchestration manager. Now we are going to start the demo. Okay, there we go. For the initial request to the platform, which triggers everything, we will simply reuse our orchestration manager, which in reality wouldn't be the case. In reality, probably other peer would be sending this request, but since it doesn't really matter for the demo purposes, we are simply going to reuse this peer to not have to set up another account. So let's see, we are going to send it to the local SmartCom email address of the platform, and we are going to set RQA as subject, which stands for restaurant Q&A. This is also the way the platform will see that this is a request to this specific service. Now, let's see, we want to know about Japanese food in Vienna, in the, say, 4th district, and we're sending this. Now the platform will immediately forward this request to the community. Since we want to show the behavior in failure cases, we are not going to respond to this first community request, but wait for the 30-second timeout, which again, if you remember, was shown here. So we are waiting for the 30-second timeout. Afterwards, the theoretical incentivizing of the community, and then the second request to the community. Let's see if we're passed. There we go. The 30-second timeout passed. We got a new request to the community. We are answering this one now with a restaurant name, and the second community peer will also answer. Let's choose the same restaurant with a different length. Now we see here that also our software peer answered to the request from the platform and provides 5 possibilities to the orchestration manager. He has also listed the human options and will now decide that this one is a good restaurant and send it. Now, since the peer orchestration manager was also the initial requester in our demo case, he will also get the response to the original request. And there you go with, okay, Machi is our suggested restaurant, and you have also a history of the different other decisions that were possible. This is easy to get rid of by simply deleting the reply message, and that's it. That's our variant A of this scenario 2. Thank you for watching. Okay, welcome to our final video for scenario 2. In this video we will show you the variant B, where the as you can see here, we switched variant A to false. We are still in demo mode. And in variant B, the difference is that the programmer of the task doesn't want to handle the failure cases manually, but instead he provides an adaptation policy in case of a failure of execution. As you can see here, the developer provided a repeat execution policy, and it will be repeated at a maximum of 2 times and then fail if it doesn't succeed. Further, another difference to our variant A is that the orchestrator has only a 30 seconds window to respond to an orchestration request, otherwise a failure will be triggered. What will happen now is that we will run exactly into this 30 seconds timeout in our first run, and afterwards in our second run we will be a little bit faster and show you that it still works. Again, we are starting up the platform. Yes, and switching to the email account. Again, we will use, like in variant A, the orchestration account itself for the initial request to the platform. Again, it's a airCreate type of request. Let's again search for Japanese food in Vienna 1040. Now, the community will again immediately get a request for action, and now we want to respond to this request. There we go, peer 1 and peer 2. Okay, we responded to the request, and now the peer orchestration manager will get a request to orchestrate. However, he won't do it and will run into the 30 seconds orchestration timeout, which is an internal execution timeout, which will lead to an execution failure. This will again lead to our adaptation policy kicking in and restarting the execution, which will happen any moment now, 30 seconds as mentioned. Okay, there we go. The community gets a new request. We will answer this again. And this one also. And this second time, the orchestration manager will respond in time. And we will get again the final response from the platform to the orchestration manager, since he was the initial requester. As you can see, the adaptation policy defined kicked in after the 30 seconds timeout and the internal execution error, and restarted the execution, since it was a repeat execution adaptation policy. Here you can also define other adaptation policies or own adaptation, or even your own adaptation policies. Well, thank you for watching again, and have a nice day.